I am in Norrköping in Sweden with Kempower. I actually drove over here in the Seeker 7X, just a short road trip from Oslo. I'm here to check out what Kempower has been up to. I'm here to also check out Megawatt Charging, and Megawatt Charging means charging of electric trucks. We did charge multiple electric trucks in this video, and also to talk with the Kempower guys about the way forward. This event was organized by them to bring the entire industry together, so we had competing charge point operators and also competing EV truck brands on the stage, which was amazing. I also got to meet Adam from the North American team, and we had a chat. So join me for this video, fully packed with electric trucks, analyzing of charging curves, and much more from Kempower. Hello and welcome to another Autospec Reviews video. Right here I have something super exciting that I just had to show you. It's just absolutely insane. It is one of the most insane things I've ever seen. It is a dual trailer 33-meter electric truck. Yes, it's pure battery electric. And I'm here at this Kempower site with Kempower, and we are checking out both Megawatt Charging. We are checking out some cool CCS charging stuff, so something that you might see in the future. No matter if you are living in Europe or the US, everything in this video is very, very relevant. And here we have a Kempower power unit. We see the Kempower liquid-cooled satellite right here, 400 kilowatts. And I have some exciting news to share about some North American stuff as well. So if you are in North America, I promise you it will be super exciting. But this video will go over Kempower's kind of future plans, the product that they have today, and how we can electrify trucks. Because like Kempower says, MCS is here to stay, and it's live, and there are electric trucks driving around all of the Nordics and Europe right now, delivering every single day. And here you can see that this large, enormous dual trailer truck is actually connected to CCS. It's a CCS truck, and a lot of the trucks today on the road, most of them by far are CCS. MCS is kind of like a brand new thing for electric trucks. Here you see Kempower's own ID bus with barn doors in the rear, which is super, super cool. That's the spec to get. And here you can see the Kempower Mega Satellite, and also you can see that it has the MCS connector on it. And we will get some trucks pulled up, plug them in, and see how they charge on this Mega Satellite. You can see the enormous MCS plug here. 1125 kilowatts peak charging from this bad boy. Of course, it gets its power from the power units that you can see here. These are connected together for the MCS part of this charging site. So 600 kilowatts together, 1.2 megawatts. And then we have a separate 600 kilowatt cabinet there for some of the other chargers that we saw. And over on the other side, we also saw the other power unit. And we have a satellite over here as well. So with Kempower, you are able to like mix and match and just set up the charging site exactly how you want it. So this is another 400 kilowatt liquid cooled satellite for inside the fence. This is actually Scania's prototype MCS truck, and I'm excited to see what happens when we plug this one into the MCS charger right here. So even with the trucks, you can charge a QR code and follow all the way if you're interested.
So let's see, now we are up at 520, 550. Yep.
Wow.
645, 650. I would assume it soon tops out. Let's see what current we have at the moment. We're up at 990 amps.
Oh, wow.
And this one takes 1000 amps, that's max. Yeah. So I think it will probably go up to 1000 if we are lucky here.
Yeah.
So that means around 600-700 kilowatts at the battery voltage. So it's very easy to find the battery voltage then, because if it charges at 680 kilowatts, 1,000 amps, that means that the battery voltage is 680 volts, of course. As the battery pack rises, we will get a faster and faster charging speed due to the voltage of the battery pack, of course, which is super interesting. It's impressive to see 1,000 amps going through that Huber-Schuner cable right there. It's so impressive. Okay, so let's take a look at the two different satellites that Kempower have here. They have this one, which is dry cables. They are 300 amps nominal each, but they can boost more. And we have this one, which is the liquid-cooled satellite, the new one, which you can see that it has this extra piece on the side here. And it's now charging this Polestar 4, which looks fantastic, with these liquid-cooled cables. So this is the liquid-cooled satellite. So if you had a fast-charging car here, you could get some pretty beefy power out from just a tiny footprint. Of course, the chargers themselves are in these cabinets. Like we know, these are, of course, 600 kilowatts each, these cabinets, and you can set them up almost any way you would like. You can have these ones, you can have the liquid-cooled satellites, and you can also have the MCS satellites, or the Mega Satellites, which is the name Kempower gave them.
They are all kind of hybrid sites. It's not just a purely MCS. And it's about the kind of unlimited flexibility, what we can offer with our dynamic system. You can basically put, is that then one Mega Satellite MCS with CCS, or is it Mega Satellite with liquid-cooled satellites, or is it Mega with the control units? We can combine these ones to provide kind of the best solution for the site. And like looking on, well, maybe I'll look on the next slide in a way, like you see in this one now already, that looking over here, by using the dynamic kind of a sharing and combining with multiple different charging options, in a way you ensure that the utilization of the site is the best, and then the return of investment is the best.
And the MCS satellite will also be available in CCS, so a CCS Mega Satellite, which I am very excited for, and I hope that I get to try one with my car one day. I'm here with Adam. So first of all, can you just tell me your role at Kempower?
Yeah, for sure. I'm Adam Wagner. I'm a senior solutions engineer. I focus mostly on the hardware implementations of our product in the field with electrical design, civil design, but I also do dabble in the software side of things as well. So anything Kempower you need, I'm here to help with.
And you are based in North Carolina, right?
Previously, yes. That's where our HQ in the US is. I'm actually based out of Utah now.
Okay, interesting,
Yes.
interesting. So North America has had its ups and downs when it comes to EVs. Despite this, we have seen companies like BP Pulse, Ionna, Mercedes, and Walmart, and many others building out like extensive charging networks. So there seems to be kind of like money and the will to buy charging hardware in the US, even though there has been like a downturn in incentives and stuff. What's the plan for Kempower moving forward for North America?
Yeah, kind of like you said, there has been some headwinds, and we really have weathered the storm pretty well. We still see a lot of growth going on in North America, specifically, as well as globally. We have not been affected too much by those headwinds either. We do see a positive bill of health, honestly, as well. People are still buying. People are interested in electrifying, especially in the fleet space as well as the public space. So both sides. And then really exciting, in my opinion, is the off-highway stuff. Stuff that you don't see. It's underground. It's in mines, things like that. Those industries are really taking off as well. So a little Easter egg there, taking off with the airport industry as well, electrifying here.
Yeah,
seeing some
exactly.
EV
Yeah.
tools.
I think that's something that many people don't think about.
Yes.
Is like the off-highway stuff, the fleets, that everything that needs electrifying. It's not just public charging off off the
Exactly.
highway, off ramp,
Yeah,
right?
and that's what you see on a day-to-day basis, but realistically, that's only just a piece of the pie.
Yeah. And I asked Antti on the stage about some amperage limits and stuff on cables and chargers, because Kempower's 400 kilowatt units have had like a 500 amp limit, or at least that's what's have been advertised. And then you came over to me and talked about something. Can you tell me more about this for the US market?
Yeah. So specifically for the US and Canada, we do have a 600 amp boost option. So when you look at any of our marketing materials or any of our data sheets, we will always publicize our continuous values. So anything you see is what you can continuously get out of a Kempower charger. We do have boost profiles associated to that as well, as long as you prepare your site correctly. So it does require sizing your underground DC wires to be sized properly. But we do have boost capabilities as well, depending on what your needs are. Not everyone needs boost either. A lot of times you can only get that 600 amps for 10, 15 minutes, depending on the ambient temperature. A lot of times the large dwell time for that vehicle, you don't need those boost temperature, those boost profiles. So save the metal. You don't need to put huge copper wires in the ground to get to that boost then. So it really depends on the application. But yeah, we do have a very large range of applications for amperages on cables, depending on your needs.
Because that's what Antti said as well. Overall, given a 15-minute charging stop, it doesn't really matter that much with a 600 amp boost for most cars. But for me, it matters because I do charge testing. So that's why I'm extra interested in that. And we also see more and more cars making benefit of this kind of boost. So that's fantastic to hear.
Yep.
And can you tell me a little bit about why a distributed system like Kempower is like the right way for charge point operators?
Yeah, for sure. And so a charge point operator, their number one thing is I want to be selling electrons, because that's how they're making their money. They're selling commodity, that's resource, energy. How do you sell as much energy as possible, as quickly as possible? That's their distributed system. So you have to pay to interconnect your chargers to the grid. The grid's going to charge you based on how much capacity you put on there. So you want to keep that number small, but you also want to serve a lot of spots. So how do you kind of make that balance of, I want to get enough energy that everyone's happy, but also I don't want too much energy that I'm going to pay a lot for that, subscription fees, demand charges, things like that. So it's a real balance. And with a distributed system, you are able to take a pretty small grid feed and then share it across many chargers. So if only one vehicle is charging, it's really happy you're selling all the electrons you can. But if a lot of vehicles plug in, maybe 8 connectors on the system, everyone would be getting a moderate 75, 100 kilowatts, which is just enough, especially for consumer vehicles. That's all you need. But you're also selling a ton of electrons, your maximum grid capacity, and then you're not paying too much for your oversubscription either. So a lot of times we compare a distributed system to standalone. Standalone systems, you do have to guarantee that energy to each one of those plugs, which then makes you have a really large subscription and then have a very expensive grid connection because of that. So we do find we can save a varying amount of percent, 10 to 20% a lot of times on the overall grid requirements.
Exactly. So a distributed system is good in that sense. And I also think that eliminating charging queues, giving everyone a plug. Okay, you don't get the maximum speed. I am always interested in getting the maximum speed. And yes, I would like a 400 kilowatt dedicated charger every time I come to a stop, but it's not really realistic. And I'd rather just plug in at 100 kilowatts and not having to stand in a charging queue and having to monitor the car. I can go do other stuff. Exactly. I can go in, do the amenities and stuff. So in reality, for most people, I think most people would choose to skip the charging queue and then taking a little bit of loss on the power. And I also like the 25 kilowatt granularity, which makes it super optimized.
Exactly. And on that same point, in America at least, the Chevy Bolt exists. It can charge at a maximum of 50 kilowatts. You're smiling because you know exactly what I'm talking about.
Yeah.
You roll to a 400 kilowatt charger with a 50 kilowatt vehicle, you're way oversized for what you need. And now someone else is waiting for that charger to be open. With a distributed system, we could have more plugs where that Chevy Bolt can get what they need, and then everyone else can also get what they need. So just as we grow with the new vehicles coming out, there will still be a lot of legacy vehicles out there, and they don't need very fast charge speeds. I think recently we published a white paper where the average charge speed globally still is like 80 kilowatts.
Yeah, exactly.
For a charging session. That's not very high, and people want these really sexy 400, 500 kilowatt chargers. Yes, they are going to be needed here for certain applications, but they're not needed for everything by any means.
Exactly. Yeah, I think you're right. Thank you so much.
Yeah, for sure.
Had our smaller trucks operating already for about 2 years. And what you see is the locations that our trucks have been visiting at the time. You see a bit around Gothenburg, you see a bit in Switzerland, a little bit in Spain as well, and then the Netherlands being present here. What do you think happened until 2023? This is what it looked like. In 2025 then, somewhere end of 2025, this is what the picture was looking like. The message I want to send is, well, you can go almost anywhere in Europe with an electric truck already today. So what we want to say over here, I'll go through a little bit what we have done and a little bit maybe history and show what we are thinking of doing. But what we want to say, one of the messages is that MCS is here. It's really happening all the time. You can see the picture over here. Okay, this is not trucks, this is ports. I'll come back to that one a little bit later. This is the biggest site, MCS site at the moment in Europe and in North America. 12 MCS chargers over there charging Kalmar reach trackers. A great, let's say a demo site, or not a demo site, an actual site which is working over there. We have also in this site, there is 8 CCS equipment or chargers charging also reach trackers. This is in total 11 megawatts. It's a huge site in London, DP World, UK getaway. Beautiful, beautiful place. So MCS is here, it's happening. We see charging happening. It is it's driven by the truck electrification, but we see also other segments happening. It's an ecosystem, as we discussed earlier, mentioned several times. It's an ecosystem kind of happening in a way. When we are moving to a new technology, you need all the players to make it happen. Actual status in a way is that if we look on the Nordic countries at the moment, we have in every single country, we have a working MCS public site, which can be used. We have the Alfredsson site here in Sweden, where we have total power 2.4, 1 MCS, and we have 11 CCS plugs over here. It's not only those ones, we also have in Finland, we have Komsu, total power 1.8, 1 MCS, and 4 Mega CCS over there. And then we have DP World UK, which you already saw, 12 and 8. Circle K, Sweden, we already covered Sweden, but there was a Circle K side as well, 1 MCS over there, 1.2 megawatt. Just kind of showing shortly how we do this one. I think this is familiar to most of you. We use our existing technology. So it's proven technology. We are putting together 600 units to make a 1.2. This one gives us a lot of flexibility, proven technology, and you can upgrade it easily.
I think we were by 810 ohms. And the reason why you see like a drop there, it's due to the temperature and the state of charge. So you have like the battery characteristics. And by this 30% point, the characteristic gives you like a drop for each battery pack, meaning that we will need to charge a bit higher. So you need to reach like state of charge 50%, and then you will get the full power.
Do we know what happened there?
I don't know. No. I don't know exactly. Maybe it's a measurement fault. I don't know. No.
Or maybe we were like adding more power modules in that.
Oh, you mean that small step there? That's probably a power module.
Exactly.
I was thinking about the small bumps in the top there, but yeah.
Oh, you noticed that one? I didn't even know. I was totally not aware of that button.
Into the details.
Yeah.
When someone plugs in, something that I found interesting is that it dynamically shows how much power is available. I already have a full video on this one if you are interested. Now you can see that we have 1100 kilowatt available again. And I have a full video explaining this at the Asko site in Norway, where I had some interviews and I went through them. I also saw the CCS version of this Mega Satellite. Another electric truck pulling up here. So now we have 3 electric trucks here, which is quite interesting if you're interested in some interviews and deep dives into this kind of hardware. But basically this is a dispenser, this is a power unit, these ones are connected together, these specific ones. I've looked at the diagrams, so 1200 kilowatts available here. I think that was it for the Kempower site tour. The interview with Adam was amazing. Adam is just amazing. Everybody at Kempower is just so great, so fun to talk to, and we're all charging nerds, looking at like charging curves over at the stage. So that was super interesting to me, and I can't thank Kempower enough for sending me over here.